Good afternoon, everyone. My name is John Bennett. I work for Graitec as an application engineer, and today's webinar will be referring to advanced steel and plant 3D workflows. Couple of sort of house rules. Everyone should be on mute, so you probably won't be able to say anything, or if you do, I won't be able to hear it. You should be able to raise your hand if you need to ask questions, and that if you type the questions in the questions dialog box that you should see on your screen, I will try and answer them towards the end of the call. I'll try and look out for those prompts towards the end. So if everyone bears with me, I think we'll make a start now. Okay, so welcome to today's webinar on advanced steel and plant 3D. So obviously I mentioned I work for Graitec, and this is a Graitec presentation today. Graitec is a reseller based for the arm that I work for is in the UK, but we are a software developer and also an Autodesk partner. So a little bit of background. As I said, we are based all over the world now. We have quite a few different presences around the world with a number of local experts like myself. We deal with CAD and BIM and modeling solutions, and we work with Autodesk as a platinum partner throughout Europe and the USA. And we offer a wide range of solutions across many different sectors of the construction and manufacturing industry. I think that number's probably a little bit out of date now. I think we have a few more offices since this slide was done, but we have a number of offices around the world, and we've been around for quite a while now, as you can see, dealing with different technology solutions and implementations. And we're quite well known within Autodesk. We're quite a fast-growing company within the last few years, and we delivered quite a few number of projects to people. A certain number of our staff are actually employed in R&D, and again, I think the employee number has actually grown since this slide was done. So, but we have our own R&D team developing solutions of our own, and also in conjunction with Autodesk. And there's a number of people throughout the organization that work at local levels to help customers individually customize and implement and make their product work a bit better. So you can see quite a few different offices around the world. And just to come back to briefly, we have a few of our own products that we obviously develop in conjunction with Advanced Steel in this case. We also have some power packs which link with Advanced Steel and Revit. We have a couple of other bolt-ons that work with it to help it enhance the package. So we write these additional macros to do bits for railings, etc., and staircases. We also have links into our design software as well, and we have some connection design packages as well available now, which help you design non-standard connections. And obviously there's the power pack which comes with Advanced Steel. You normally get that sort of comes free if you subscribe with us, I understand. So there's a couple of little packages there to look out for. You can find more information on the web if you go and have a look. So moving on to the focus of today. So we're going to have a quick look at the two platforms, Advanced Steel and Plant 3D. I'm hoping that most of the people here are familiar with one or either of those, or even both. I'm going to try and show collaboration and workflow between the two platforms that I sort of have used in the last couple of years, working with a number of clients in the oil and gas industry. Typically, most people use the plant project as the master file. Other things are subordinate to that. They use a series of X references, so they'll have various plant elements that are X reference files, and then they'll have a master file, which is the middle image. And then part of that, it normally comes in and is formed is the steelwork. So the steelwork sort of gets chucked in as a secondary consideration, and depending on what the design company or engineering service provider is doing, depends on the level of detail that needs to be achieved. But all this information is digital information and can be transferred between these two packages, and that's what I hope to show today during today's presentation. So let's go ahead and get started. I'm going to switch over to using a live session of Advanced Steel and Plant 3D and show you my collaboration workflow and show you a little bit of an insight behind some of the Advanced Steel operation and modeling and drawings, etc. It will be quite a quick insight into that because Advanced Steel is a very extensive program, as is Plant 3D. So I'm just going to go here. So this is the Plant 3D project that I've got today. It came from a colleague of mine who works on this in our Houston office. So he very kindly lent it to me, and we were looking at some of solutions here that we could hope to work with for Advanced Steel and make it work with a plant project and get it sort of embedded inside it. So those of you familiar with a plant project will obviously understand the interface across the top here. It's a ribbon-based system. Obviously I'm on the structures tab here. You obviously can create your projects in here depending on how you want them, and typically people would structure the project and possibly have a master model with a series of subordinate models to that. Now in this model here, this is the master model, which is the ballpen one, and you can see there's certain elements here are X references, and obviously there we can see these. If I click on that, that's obviously the X reference file, the separate file on its own. So this is a combination of a couple of X references together, and then that's just the separate stair tower on its own. So typically what would happen in a plant project, from what I understand, is people would model certain elements in here. They would then obviously transfer elements, would either be done internally or externally. Now sometimes people just put some steelwork in, but they don't normally go down to a very high level of detail, but sometimes there is a requirement to do that. So you can see in this project here that I've got nuts and bolts in for the steelwork, and I've obviously tried to marry up with this sort of valve arrangement here and the pipe supports for it. But also I've had to integrate and create a staircase and supporting steelwork for that within the confines of the location and the associated structure. Now originally someone would have probably detailed something fairly basic inside here as what they would understand as a rudimentary layout. But obviously as a steelwork detailer specializing in stairs and connections, etc., you might need to reconfigure that slightly. So normally some of you would have probably seen the videos. There's several videos out here about using this route in and out of Advanced Steel, and also out of Plant 3D, which is to export via the SMLX file. This creates a transfer file inside the system, and you can use this to import into Advanced Steel. Now with slightly more complex items that possibly require a bit of license for you to modify it and change it, sometimes it's probably not best to work in that method. You might be able to create something as a reference file and then use that as a basis to create your own steelwork over it. That's effectively what I did with this steel tower here. I took the original file here, and I used that as a source file in combination with the vessel file, and created a separate file which is actually the steel drawing file. So in this case here, that file is under here, so you'll see that it's here, and it's actually the stair tower. So this is the stair tower model here. Now I'm showing you in the finished state, and I will show you how I get to that and how I get this inside Plant 3D. But I just wanted to get into the fact straight away that this actual element here is actually an Advanced Steel element, and I'm actually inside Plant 3D and I'm viewing it. I'm also viewing all the connection details that are shown relative to it, which have been put on using the various tools available inside Advanced Steel. You will also notice that in this file there are some other elements, some other X references, which is the vessel there, so you can see that is sort of hidden away in the background. So I've used a combination of workflows to get all this together. So this is the workflow inside Plant 3D with the X references. The important thing is this is an Advanced Steel file actually embedded under the Plant 3D project. You can see it in here within the Plant project tree. So how did we go about doing that? How did we sort of figure out this workflow? Well, obviously, when you create a project in Plant, it obviously has a structure which is obviously set out inside and at a Windows level. Now, typically, you would probably come into your project here and you would go add a new folder. So you would want to add a new folder into the system. And when you go to create the folder, you would have an option here to create the template that's selected for a new drawing. So in this case, what we did is create a folder for Advanced Steel and mapped it to the Advanced Steel template. So that's this folder down here. If we look under the properties of this folder, you can see that the actual template it's going to use is the Advanced Steel DWT file. So if we go create new drawing, it will come up and obviously give it a name. So if I put test and put today's date in it, just to show me creating it, then we can create that file. So it will create a new drawing. So that drawing is created and embedded under the Plant project straight away. And the important thing to remember in here is that the template needs to be an Advanced Steel template. The reason for that will become apparent shortly. But I can tell that just by looking at here, looking at the layer structure, I can see it's an Advanced Steel template. So if I actually close that file down for a moment, I don't need to do anything with it. Probably going to close this down as well, so I'm not going to save any changes to any of these here. I'm just going to shut down a few files or else it gets a bit complicated. And just close that one down. So now I'm going to swap across to Advanced Steel. So this is Advanced Steel. It looks very, very similar to Plant. We have a thing called the Project Explorer which sits here, so similar to the other sort of project manager inside Plant 3D. We can create various elements in here, model views, queries, group objects together, levels, etc. to help us navigate the model and turn elements on and off. Advanced Steel still sits over the top of AutoCAD. For the 2018 version, we have the first version that's actually what I call a true vertical. So you don't actually need to install AutoCAD, you get it with it. It's just sat in the background. So if you want to use normal CAD, you can draw lines, you can delete stuff, you can create stuff the same way you can in AutoCAD and the same way you can in Plant. The element that you see in the middle is actually an Advanced Steel object that has been created. And what it does, it accesses the library in the background, which is basically a database. So you can go in and look at all the different sections, all the different sizes, and change as you feel appropriate or as you require. So how do you do things like that? You just create one here, give it a reference point to start from, and you would draw a beam. It would then come up with the properties dialog. You can then access it and change it. There's a number of different tabs in here. They'll all have different functionality, and if you've been trained in using Advanced Steel, you would be familiar with these and have an understanding of them. But basically they're used to control the material types, the positioning of the objects, the numbering, even down to the fabrication data, and even how the object appears and its actual behavior within the model. So we can draw other things like simple plates, which you just draw a rectangle, it will come out as a plate. In the Sim system, it's very similar to just drawing a normal rectangle. Things tend to have grips on them. That has a grip on the plate. This has a grip on the beam, so you can drag it and stretch it. So what we end up doing is using these kind of things in combination with a few other tools and elements that are available in Advanced Steel, and we put joint macros on things. A joint macro makes a combination of a plate, a weld and a bolt and things like that. It brings it all together in one. So you don't actually need to model everything individually. You can just model it using the tools inside Advanced Steel, There's library stored in here. Once it's in place, you can come in and start editing it as you require. I changed the plate thickness there. I changed the projection here. So if I wanted an inch, I would just change it. So all these elements can be configured and stored. If you have a library of your own that you always want to use, you can set it up. But this is the basis of advanced steel. It basically models the steelwork as you would fabricate it in the real place, placed inside a model. The basic operation is pallet based across the top, but you noticed I just touched on a couple of pallets just then to do things. These are advanced steel pallets. They're quite unique to advanced steel. There's a number, some commands you might think quite recognize, copy and things like that, but they are advanced steel ones. UCS based commands obviously for manipulating the UCS positions or setting it up. Some of these are very similar to the AutoCAD commands as well. So the interface should be quite easy to adapt from using plant because it's a very similar environment and similar operation. So a few minutes ago we actually created the model that we did inside the Plant 3D model. So how can we get to that from here? So obviously what I've done is I can go in here and I can go and look and map, browse to wherever the file is inside the plant project, and you can see the file listed down the bottom here. So if I now open that file, okay, I'm now in this model. So what I could do is I could link an X reference into it if I wanted to. So I can just use the X reference tools here. I can obviously come in and sort of look at the things that I want to X reference in. So here I'm going to X reference in the stair tower, and I'm just going to let it sit inside the model. So we can now see this inside Advanced Steel. This is actually an external reference file and it's a plant base, so I'm seeing this courtesy of the object enabler from Plant 3D. I can obviously open that inside Advanced Steel if I want. I can't adjust anything, but what I can do is I can view the properties of elements in here if I need to see what they are. I can also measure to it and things like that. So basically it's the same operation as you would do inside plant itself. So how do we go about working with this? So obviously we have this in place. So what we could do is we could come in and put a column in. We can use normal AutoCAD snap points to actually position elements inside here. So I'm actually going to pick this point here and this point over here. It'll bring the column in. Now I'll probably bring it in as the wrong size. So obviously we can come in here and change the size of the column to whatever we want. So we can scroll up and down in the list here until we find the suitable size of column that we might require. So I'm just going to go for that one. I can then change the position of it. So in this case I'm just going to change its rotation, and you can see it's moved it round. With that in place, I could then come into here. I could put a connection on it. So for this instance I'm going to put a connection on the base plate. That's an additional option if you want to add it to concrete. We can attach the connection to a concrete for the base design. You can also do connection design inside Advanced Steel. So here we're just adjusting some of the elements in here, so I don't want any of that in there. I want the plate dimensions here, so if I just change that to 1 inch. So quite quickly you can see that I've sort of replicated the indication of what was required for the joint on the end of the column. With the column in place I can obviously still adapt it if I need to, even though I have the connection on the end. So I can use some of the tools over here. So in this case I'm going to use a point filter, and again I'm going to use then a separate snap to go between 2 points. So I want to go to this height. So with that in place, you know, if I wanted to, I could probably just copy the column on its own. Okay, so I can probably pick a common point, say here. And you don't, you know, obviously if the column's a different size, you might click to a different snap point in the model. But quite quickly you can use that just from starting one simple operation to create the objects. So I copied the column around. You could use other tools we have in the system here to copy the joints between the system. So here this is what's called a joint copy multiple. So in this case you would pick a column or a series of columns depending on which of the tools you've chosen, and it will apply the joint to the source parameters. So the idea that I'm promoting is that you use this to try and help you build a model based upon a scheme that someone else has sent you that might not be quite correct and in line with what you think it should be. You might need to change the level of the steel beam that they've indicated where it needs to be, but you might find that when you work out the rise of the stair and the platform level, that this beam actually needs to be at a different level to what they actually told you it should be at. So you can use the guide to start off with, and then you can work your own detail around it. Then at any point you can obviously unload that external reference file, but it still sits in the background. You haven't lost that. Whereas I think you would lose that with an import export, because the import export just brings in the file as it was intended. It doesn't actually give you the option of keeping it in one place. So for this kind of more complex operation, this is my approach to doing this. So just to show you that obviously now I've created a few bits inside Advanced Steel and I've added those into the model. I'm actually going to close that file down. I'm now just going to come back to my Advanced Steel, to my Plant 3D project, and I can see in here the file is listed, and I'm going to obviously open that. So now I've gone back into the Plant 3D environment and I'm seeing the Advanced Steel elements are visible, again, courtesy of the object enabler inside the Plant 3D file, even though they are Advanced Steel elements. And I can still see their properties because they're all listed under the AutoCAD properties of an Advanced Steel object as well. So what you would do with this sort of workflow is obviously now this is attached to the project, it's embedded inside the plant project. It can then later on develop, the model can be created further down the road. Obviously it can be attached and incorporated into the main overall master model series, so you can bring it into the master model when it's completed. Also obviously as this progresses, so this version of the model, I have a different version obviously here for what I'm doing. You can see that I've added in a lot more detail in here. You can see the original vessel shown on the side there. You can see that I've had to manipulate the steelwork around the edge to miss the edge of the vertical vessel. I've also obviously conscious that I needed to maintain the pipe support position here. So this gallows frame here, I've actually created some supporting structure and connection details for it. And then obviously I've looked at the staircase and tried to adjust the staircase and the relative levels for that. And again, I'm still maintaining the original files that I used. So if someone comes and says, well, where did you get that from? So you can just see I've just reloaded the original stair file in there. So you can see I had to adjust it quite a bit to get it to work with the various sort of standards that are required for run and rise, I think you guys call it in America. So, or in the UK it's going, and so for the stair. So to comply with whichever parameters you need. And I adjusted the top floor level, the beam levels, you can see it's moved slightly to give the support for the open mesh flooring that sits over the top of it. So I'm just going to unload that element again, and also I'm just going to unload that for a minute. So hopefully that it's a quick insight into the modeling, because obviously we only have limited time today, but hopefully you get a feel for the sort of workflow there. There's a lot more tools in Advanced Steel that you can use to get what you want. What I wanted to sort of touch on was obviously if you wanted to produce some drawings, okay, so typically people end up needing to get a drawing out of the system at the end of the day. So you can see I've been in here and had a little play around with some drawings, so I just show you. So this is a drawing that's been created from the Advanced Steel model, but inside Plant 3D. So using that same process, okay, we can come in here and we could create a new drawing or a new ortho view. So if I went, you know, create new, so this will be a new file. So if I call it new file 070717, so it'll come in as the various processes that are needed. Now, depending on what you set, obviously, you can come in and obviously adjust the view, and you can see that I can probably get to a snap point quite quickly, just adjusting this inside the plant project, and then obviously we can change the scale for this to make it a bit bigger, and then we could obviously change which view direction and stuff you wanted to view it from. Okay, so and then you could just go OK, and it'll go off and it'll come up with a dialog, and it should generate the image. Now, bearing in mind that the objects that I'm actually using here and creating are Advanced Steel objects, so they're not plant objects, they're Advanced Steel objects in this case. So I've now created a view of this inside inside Plant 3D of an Advanced Steel model. Similarly, you could obviously edit the view. So if you wanted to, you could edit the view here. So it will come back in. If you wanted to change something in here, you could. Okay. So you could change the model selection, for example. If you wanted to, you could probably add in back, say if you want to add in the ladder vessel. So that'll bring that into the drawing now. And obviously you could change the view and the depths here. So if I wanted to change this a little bit, I could just drag that up maybe slightly. Just come and bring it up there somewhere and just adjust that, and then just go OK. So I'll run through the process again and recreate the drawings, etc. So the idea of this was to try and indicate that it would actually show a combination of the plant models and the Advanced Steel elements and produce the drawing inside Plant 3D. I'm not sure whether people always do that or whether they would need to do that. I just wanted to see whether it was possible to do that myself, because I was asked that before. So obviously you can go on and you can carry on inside the Plant 3D. You could create an adjacent view to that if you so wished, just by selecting it. So if we wanted a left view or something, or a right view, we could do whichever one we want of those, and then obviously we can place it inside the model here. Sorry, inside the drawing, I should say. So again, it's going to go and create it. So this sort of gives a round sort of trip to me that I can sort of generate a drawing if someone asks me, you know, of the combined sort of shape to try and help it, show people what's going on. Obviously, I've still got the model, etc. inside Plant, and I've also got the Advanced Steel model. So this is stored, it's all under the Plant project, everybody can find it, everybody knows where it is. It's even stored actually within the system totally. It'll obviously be stored within the structure of your Plant project as well at a Windows level. So I'm just going to come in and I'm actually going to just close this drawing now. So I'm just going to shut that one down as well, so we don't need that one at the moment. Okay, close that one. So what I wanted to do now was just flip back to Advanced Steel. So I'm just going to go back to here. So I'm going to now go back and open probably stair vessel 2 tower, stair tower vessel 2 tower drawing. So this is the same file that we just saw inside plant that I created a drawing from. So doing the same thing here, I could go off and create drawings. Now creating drawings in Advanced Steel is slightly different. In Advanced Steel we have a series of palettes that we actually use. There's an installed Advanced Steel part and there's a user part which you can sort of configure and change. And this is what we end up doing at Graitec. We normally end up customizing this for people to give them what they want, and we add a few extra camera types in and we change the actual drawing content, which is actually the style behind it, and we customize the border frames and stuff to match what people require. So typically with Advanced Steel I would use a thing called a camera to produce a drawing. It's very similar to what you saw with the model and view selection inside the plant project. It's basically looks at it, and instead of showing a cube it has a little sort of central plane. This is the view plane, and then you have a front and a rear, and if you want to you can change it and restrict it on all 4 sides. But just to show you what it actually produces, once it's actually produced the camera, use the camera to produce the drawing, I can actually show the camera detail. So this has actually produced the drawings from the model based upon the cameras that I've already placed in the model. It's the same sort of thing. In this case I've only got the steel showing. I haven't bothered to show the plant objects in here. So sometimes people do drawings just to show the steel. Sometimes they do drawings to show a combination of things. So that was just accessing one drawing inside Advanced Steel. If I actually show you here, we have a document management system inside Advanced Steel, and you will see that here there's a few drawings have been created for this project. So these were the drawings that I created prior to today. So I just ran those quickly from the sample cameras that I put into the system. So you can run individual cameras by selecting here using a button here, or there's individual camera types can be selected to produce different types of drawings. These are all linked to particular styles. But sometimes people, we also end up sort of just doing this for people. Sometimes we create little suites of things to try and make it run a set of drawings in sort of a sequence and an order that's required from the model. So I'm just pressing the button there, and I'm just going to let it go off and run some drawings. So basically I'm going to replicate what I did this morning. So what I've done is obviously I've set the model up beforehand. This would represent like if I was modeling for a project, I might put some of the cameras in place as I go along to try and help me determine my final set of drawings. So that's now completed running those drawings. You'll notice from the list there we got up to drawing 3011. So if you recall from looking at it before, the other drawings finished at 3005. So now we're starting here with an isometric again. So this does all come down to the configuration and the customization of Advanced Steel. The physical content of a drawing can be adjusted. So what you see in the way it's being labeled, etc., the level of detail that you see, whether you want to see nuts and bolts and cleats and stuff like that, can all be configured if you want to see the hidden detail, etc. How the label is configured, this is all part of Advanced Steel. So what you do, it uses a series of tokens which are basically attributes that link back to the data associated with the objects in the model. if you change anything in the model, it will tell you that you need to update things. So for example, I'm in this model, if someone decided all of a sudden they want to draw a piece of steel somewhere, so just for example, I know you probably wouldn't do this, but maybe someone wants to hang a beam off the side here. So as soon as I do that, as soon as I make that adjustment inside here, I'm just going to shut that drawing down there. As soon as I do that, if I click on anything here, it will tell me that the drawing is out of date. Now obviously I have two drawings the same because I ran the set of drawings twice here just to show you. But see, it's picking up and saying they're out of date. So even with that in place, we can then use our document control system in here and actually come in here. So what I'm going to do is it's telling me the drawings that need an update. So I can actually just click on this and I could add a revision mark if I want to. If I do an update revision, it will add a revision index. I can put in here, test beam added or something like that. You type a little note in there and you just go OK. Now it might take a few minutes to actually process that and do that. So I'm hoping it doesn't take too long. I normally go and make a cup of coffee when I'm doing this myself, if I've got lots of drawings. So it's managing the project for you. And what it will do, it will actually create a backup of this as well. So the original file will be kept and stored in the background. And then it will actually give it a new revision mark. So we can see the drawings that have changed with a revision mark here. Okay, so they have an A against them. So if we go in and open that drawing, okay, so you can see it just ballooned that little area in there, and that's where I actually just drew that beam on. I actually just added it into the view, and what it will do is it will come in and it will add a little revision mark in here. So it's added that into the table. That was the note I typed in there. And then obviously down here it'll put a revision in here. Now depending on how you want this configured, this can be configured as well. It has a series of attributes that are available to be populated from the model. Normally we can match that pretty much to what most people want these days. Sometimes we can't get all the attributes, but you can add your normal attributes in and go in and edit them anyway afterwards if you want to. So I'm just going to save that drawing. So obviously we do other things with it apart from GA drawings. Obviously if you need to go to a fabrication level, you can actually go to a fabrication level for drawings. So I'm just going to draw this column. I'm just going to run this column on its own. So you can either run all the drawings, all the bits together, or run them separately if you want to. And then I'm just going to go in and show you the assembly drawing. Now depending on where you are in the world, depends on which way around you draw the column. Some people draw it horizontally, some people draw it vertically, I've found on my travels. So don't be alarmed if you see that vertical and you think you want it horizontal. In the UK we tend to do it horizontally. Similarly, you can come right down even to, so I can pick a part here and do the same sort of thing here. So I'm going to do a selected part, put it on that size sheet, and you'll notice it's given it a slightly different number. So with the part in place, I can then obviously pick on here, select the plate, and it will go show part detail. So again, it depends on where you are in the world. You know, if you want millimeters, then the drawing styles and the templates and all that are set up to work with millimeters. This is obviously an American project, an American install, so everything's in feet and inches. So that's the essence of the collaboration between the two platforms. Obviously, we've sort of worked out these workflows to enable people to sort of work together and between different elements of the project, even within the same company with different departments. Some people only have plant, some people only have advanced steel. When you've got object enablers, you can see each element inside it here. Just for example, I'm just going to actually reload the so that's the stair model, so you can see that. So just unload that a minute. I'm going to reload this one. This is the one I want to reload. So what I wanted to do, obviously, would just show that I could do a combined same sort of model here, a camera. I'm going to do a selected camera, I think, on the selected camera. There we go. It's probably that one. Let's do it on an E size just to see what it does. So I'll pick a different size sheet for a change. So again, if you're in USA, you'd probably, you know, A, B, C, D, E size sheets. In the UK, A1, A0, A3, A4, those kind of things. So that'll be the last one there. I just wanted to see. So again, this is this has actually been run from a slightly different process, but just to show you the same thing there. So that's how it's set up to run for that process, the colors and everything, and the way it's been detailed. And this is a standard process that's available inside the system, so it will still work out of the box. All we've done is slightly customized it for people, so when we go and do it. So if I click there, if I was to do the same thing with this one, and I'll just do a selected camera here. Okay, so I'm going to run the same camera again. It's going to go to drawing 3013. So, and go and show that. So okay, so slightly different convention now. Obviously, it's been labeled. Okay. Also, you'll notice that the naming of the file is different between here. So we've adjusted the file naming here. So certain things you can add into the file name selector if you need to come up with it how you want it. And obviously also you can change the content of the style as well. Even this, the header of what's in here, how it's labeled, what it labels, what it doesn't label. And if you, to be honest, you know, this is obviously an element. If you didn't want to see it, you can actually, if there's something in a view that you don't want to see, so for example, I added this beam in just now, you can actually delete it from the view and then update the view, and it won't turn it back on again. So it will remain as it is turned off. So I'm just going to save the changes to those files. Save that. So that's basically the sort of input to Advanced Steel and also the input to Plant 3D, and my sort of workflow between the two to work with more complex sort of interactions rather than just drawing a piece of steelwork that you're not really concerned about anything else that's around it. I think you need to have an awareness of the other elements in a plant project, especially. There's a lot going on normally. So I normally end up having to alter something to fit around something or suit something else. So I like to have those sort of references in the file as a source that I can go back and refer to, and I can turn them on and off. And I can then take the project to full engineered level and then even send that model on to a fabricator if they had Advanced Steel or another detailing house. They could take that model, complete the model with the connections, and then even send it back to you, and you could link it back into the Advanced Steel project, which is then part embedded under the plant project as well. So that's my workflow for this Advanced Steel and Plant 3D. I noticed there is one question, so I'll just try and do this. It says the ortho template. Not sure what that means when I'm not trying to read it. Sorry, let me just try and read that and see what it says. Can you create an ortho view to look? So you're asking, I assume the creation of an automated bomb within Plant 3D is not possible. Not possible for the steel, I wouldn't have thought, because it is part of the Advanced Steel, but you can create bill of materials for advanced steel elements, you would use BOM templates here. Depending on which type of template you wanted. So here we could go for a material list. I think is a fairly okay, so I'll just see what it runs. So you would normally produce all the steel schedules from within the steel package, so it will cover every element that you've actually done. I wouldn't think it would be possible from plant. You would do it from advanced steel. These, again, all these templates can be configured and changed. I recently did that for a company in the USA to match their manufacturing process. We aligned some of the elements of advanced steel to the BOM templates and how they produce their drawings, etc. If you do this, this file can be also exported into an Excel spreadsheet, a PDF. So you just press this and it'll go off and it'll want to create it somewhere. So if I go here, material list 070717 and go save. And what that's actually done, it should have put it under here. You will find the material list. So that's the material list I just created. It's been exported to an Excel spreadsheet. So I hope that answers your question, Nick. Does anybody else have any other questions regarding the advanced steel and Plant 3D collaboration? Okay. You can obviously save this source file as well. If you save this, it will actually store it inside advanced steel as well for you to later call it back. It will become part of the document management system. So I'm just going to switch back now to my PowerPoint at the moment. So let me just go back to that and go to my next slide. So I just wanted to mention as well, obviously we've just done some work recently in the UK working with Faro where they've been scanning and stuff and using their scan data. You will have noticed probably a toolbar that was on my screen. That's to do with Faro. We did some work with them, some collaboration on a project, so they have some really nifty tools which work quite well with Plant 3D, and obviously they have one that works with advanced steel. It uses the database from advanced steel, so you can actually map your elements in there and get them straight in as advanced steel objects. So I know that's sort of becoming more and more of a thing that people are doing nowadays, so looking at collaboration from that side, so taking the data right from the source, from the site, and then bringing it into a model and collaborating and working with it. So obviously that was to say any questions which I sort of asked. So if anybody else did have any more, I can't see. I can only see one in the list at the moment. There's another one. Just they don't make it very easy for you to see it. So when you reference the steel drawing into the piping drawing, it gives the center of gravity correct work for both combined. Probably not. It will give you the center of gravity inside advanced steel for the steel work. I don't think it will give you the combined center of gravity for both elements because they are two separate models. Okay, so if you want to use one of the questions here, would you normally create a simple structure in Plant 3D? Structures are very simple compared to your example. Would you recommend not using the export workflow? Depends what you want to do with it. You can use the export import workflow. I think you need to be careful how you model the steel in Plant itself. I found some problems with that where people have not modeled it correctly, with the correct positions, etc., and it doesn't transfer properly from what I've seen. Might be slightly better in 18. I know they had a couple of alignment issues in the USA for positional issues, which is why we probably did this workflow. Can we use Plant 3D custom template in AS? You would probably combine your Plant 3D template with the AS template, but we would need to look at that because you can change some of the elements how they're mapped. We use a particular template in Advanced Steel because you might have noticed that it puts all the elements on certain layers. A lot of people like to work with elements in certain layers, so you can drive, for example, beams onto a beams layer, columns onto a columns layer, plates onto a plates layer, bolts onto the bolts layer. So we use layer technology from Advanced Steel. So you could probably combine the two together, I would expect, but you would need to set the same as the default and make sure it works. It will work. The thing you need in Advanced Steel is you need to have the standard layer to activate the layer assignment. So when that's active in the system, it automatically puts the object that's created onto that layer. So I think that covers those questions. I think I answered your first question, Nick, about the using the import-export route. I was going to say if you haven't seen that, there is, if you just search on YouTube, you'll find that this was the video done by Autodesk on the workflow using the SMLX file. So that's why I didn't bother to cover it today, because it's already out there. Okay, so let's just go back to here. So obviously just sort of trying to bring it towards a close now for today. Obviously Graitec, we're looking to be your partner, etc. We try and help out with things. I spend most of my time out on site helping people, customizing their systems, implementing it, looking at their workflows and trying to figure out the best way to work with their workflow and get Advanced Steel to work with it, and also a bit of give and take on either side. So I spend a lot of my time doing implementations and recommendations to customers on how to get the best out of the product to work within their environment. So that's that. So we obviously have a number of Autodesk products as well. So we're a platinum partner, so we support all the Autodesk products across the range. There are more AEs like me that work with other applications like Revit and Plant, etc., and even Inventor. So we have full range of services available within our company to cover obviously not only Autodesk products but also our own Graitec products as well, which we'll combine in with Advanced Steel and Revit. And as I said, we have a number of people delivering services in the company across a wide, broad spectrum of industry sectors. So obviously today I expect most of it's either MEP or plant, oil and gas. I have also used plant inside the food processing industry as well. So a couple of contacts there. Tom's obviously the main one in the UK. Some of you probably know him, have met him. So obviously if you want to speak to me, my email address is down the bottom there. It's quite easy. It's just john.bennett@graitec.co.uk. I think some of the guys on the calls today I've probably got a meeting with next week, I think, I understand. So that sort of really sort of brings it toward us a conclusion for today. Obviously, I hope you found it informative. It probably seemed a bit rushed. I hope it wasn't too rushed. There was a lot to cover in a very short space of time. I'm just trying to really show that it is possible to work with Advanced Steel and Plant 3D in a collaborative manner, and it's quite easy to work between the two platforms. It's not as scary as everyone thinks. So hopefully you found that good. I look forward to any comments, etc. Please reach out to one of the guys in the team if you want to arrange a further demo or a visit, etc. I'm sure they'll be able to set something up for you. and thank you very much for your time today and for attending. Goodbye.